So maybe you don't know JavaScript, maybe you don't know Python, maybe you don't want to have to learn one of these languages to deploy your smart contracts. You know how to code Solidity, you know how to do command line, you know Bash, you know Linux, and you're ready to deploy your smart contracts and you want to use those tools if only you could. Well, you can. DappTools is a powerful, minimalistic, command line based tool to help you create, test, deploy, and interact with your smart contracts. It was written with Haskell and is the primary tool used by the MakerDAO team, the team behind the DAI stablecoin. More recently, the Paradigm team has taken this and made a Rust implementation which does the exact same thing called Foundry. Today, we're going to be learning about this fantastic DappTools tool. However, everything that we teach you will also apply to Foundry. Just a couple of commands will be a little bit different. DappTools is a great option for a smart contract development framework if you like minimalistic, command line based tools and you don't want to have to learn Python or JavaScript or any of these higher level languages to do your compiling and your deployment. Today, we're going to learn how to make an advanced project ourselves using the DappTools starter kit, which is in the smart contract kit repository. So let's jump in. And here's our agenda for the video is going to be. First, we're going to set up our coding environment. Then we're going to install some requirements. Then we're going to walk you through the quick start. And then we're going to make a new lottery contract from scratch using DappTools. We're going to write it, test it, deploy it, and interact with it. So let's first get our coding environments set up. I'm using Visual Studio Code as my code editor. Link to it in the description to download it and get started. Make sure you don't download Visual Studio. You want Visual Studio Code. Visual Studio is something different. You want Visual Studio Code, not Visual Studio. Along with Visual Studio Code, I'm using the Solidity extension. So just look for this little thing here, look up Solidity and install it. I'm actually using a different Solidity extension, but this one that shows up at the top by Juan Blanco, this one that shows up at the top right here is fantastic. Additionally, I have a MetaMask with some testnet Ethereum in it. Also, some testnet Link. We have a video on this to both install and set up MetaMask. If you need testnet Link and testnet Ethereum, you can come here to faucets.chain.link, just put your address in and get both testnet Link and testnet ETH. Once you have VS Code open, you can hit File, Open Folder, and you can even do a new folder, and maybe we'll call it DappTest. Great. And then we'll go ahead and open it. Now, if you hit Terminal, New Terminal, a terminal will pop up here, and we'll be using this a lot. I'm going to be using screencast mode, so anything I type will show up on the screen like this. All right, great. Now that we have our coding set up, let's go ahead and download the requirements. Now, if you're on Windows, a lot of the commands that we're going to be working with might not work for you. So I highly recommend installing WSL and working with WSL so you can run all the Linux commands. I'm working on a Mac, so all the commands you'll be seeing me do are going to be Mac commands. Now let's go ahead and get into the Dapp Starter Tools kit. Again, a link in the description to get this repo and work with it. The first thing we need to do is download some requirements. So we need to make sure we have Git installed. Link in the description to install Git. You can make sure it's installed by doing git --version. You'll also need DappTools installed. So you can come to the DappTools GitHub repo. Link is in this, our DappTools starter kit repo. Look at that super cute logo. And you can scroll down to installation. So first you would just need to copy, paste this into your terminal and run it and hit enter. I've already done it, so I'm going to skip that. And then same thing, copy paste this into your terminal and hit enter. Once you've done this, you should have dapp, sulk, seth, HEVM, and ETH sign in your terminal. You can check by doing dapp --version. And you should see something like this. You should also have the make command already installed. This should be installed by default, but just to double check, you can do make --help. And you'll see something like this. All right, great. Well, now that we have everything installed, we have all the requirements, let's do our quick start. This is where we're going to just quickly show you the functionality of this repository and what it can do. It's a fantastic template for working with code and getting a project spun up. So we'll do git clone and we'll paste that address and hit enter. And we'll see something like this. And then additionally, if you want to work with the exact commit that this video is working with of this repo, what you can do is you can go to this commits, you can click this commit, copy this commit, and do git checkout, and then paste that commit. and now you're going to be exactly at the exact same commit we are for this video. But that's optional. Main is always going to be the most up-to-date branch anyways. And great, in the left here, you'll see a whole bunch of files get pulled in. Let's do a quick walkthrough of what each of these do. The image folder is just for some cute DappTools and Foundry Chainlink images. The lib folder is going to be different libraries for external packages that we're going to be using, like OpenZeppelin and other Chainlink contracts. Scripts is where we have a whole bunch of bash scripts or command line scripts for working with our contracts. SRC is where we have all of our Solidity code. This is similar to contracts folder in Brownie or Hardhat. .dapprc is a configuration file similar to the Hardhat config or the Brownie config. .env.example is an example.env file, which we'll get into in a bit. These .git files are GitHub config files. We have a license file for the license of our code. We have a make file, which we'll get to in a bit. We have a README, which just has all the instructions, remappings, which we'll talk about in a bit, and shell.nix, which we'll pretty much ignore. All right, cool. But once you have everything installed, we can start working with DappTools. So let's go ahead and CD into our DappTools starter kit. We can compile all of our contracts by running dapp build. Whoops, actually before we run dapp build, we need to run the make command. In our make file, when we run the make command, we need to run this dapp update to download all of our external packages, because right now some of them are blank. So let's go ahead and run make. Running make looks at the make file and just executes the first command it sees. And the first command it sees is dapp update. When you see a colon followed by a semicolon in a make file, that means this is going to be a command, and this is the first command it sees. We could also just do dapp update, which does the same thing. And now if we look at our lib, we see these are now installed. Now that we have installed, we can now run dapp build. And we've now compiled everything to our dapp.sol.json. We can also run tests. We can either do dapp test, which is the dapp version way, or we can do make test. Because in our make file, we have a test target, which just runs dapp test. So make test or dapp test are going to do the same thing because our make file says, hey, if you say make test, you're going to run dapp test. We could also run make build, which runs dapp build. We could run make clean, which runs dapp clean. You get it. So let's go ahead and run make tests, and we'll run all of our tests here. And we can see that they all are indeed passing right now. Now, I'm not going to be showing how to do the deploy in the quick start, but as we go through building our lottery contract, we will get to that section. If you want, you can go ahead and skip ahead to the chapter where we work on actually deploying and interacting with these contracts. But that's the basic breakdown of what's going on in this repository. You can make all your contracts in here, add all your tests in here. The tests are in Solidity. They're not in JavaScript or Python or anything. These are tests right in Solidity. But okay, cool. So you've git cloned this template and now you're ready to build some awesome smart contracts. Let's go ahead and start from scratch on what doing something like that would look like. Let's say we wanted to build a lottery contract. That's going to be the purpose of what we're doing here. So let's go ahead and create a new file in our source folder called dapplottery.sol. Now the contents of this file don't really matter so much. In fact, we're just going to borrow the VRF consumer code that comes pre-populated to populate our dapp.lottery. And we're just going to change this to dapp.lottery is VRF consumer base. And we're just going to change get random number to start lottery. And that's it. What this Solidity does is it imports the VRF consumer base from the Chainlink code. Definitely check out docs.chain.link to learn more about how the Chainlink VRF works. We have a constructor, which takes a ton of different parameters for working with the Chainlink VRF. And we have a start lottery function, which starts our lottery using a request randomness call. And then the Chainlink node has a callback function called fulfill randomness, where it'll give us a provably random number, obviously for a lottery. This isn't the full implementation of a lottery, of course, but it's definitely the starting pieces of one. Now that we have a contract, what is the first thing we'd probably want to do? Well, let's make sure it actually compiles. So we'll do dapp build, and it looks like there were no compilation errors. So that's great. There are a couple of warnings, but we can ignore those. Now you'll see at the top, we're using this @ syntax to import VRF consumer base. DappTools knows that this @ sign is actually coming from our lib. How does it know this? Well, in our dapprc, we have this export dapp remappings equals cat remappings.txt. And if we go into this remappings, we can see a little key here where it says @chainlink/ equals lib/chainlink brownie contracts. This means that anytime DappTools sees @chainlink, it's going to look in lib chainlink brownie contracts for any contracts. And that's exactly what we have here. Awesome. So we've written a smart contract. What's the next thing that we want a framework able to do? Well, we definitely want it to be able to test our smart contracts. So let's go ahead and set up a test for Dapp Lottery. So in our SRC folder, we have a test folder, and it has a number of different files in here. You'll see it has mocks, utils, and then these tests here. Let's look at counter test to get a good idea of what these tests are doing and what's going on with these, because this might be the first time you've actually done Solidity tests. The first thing you'll notice is, of course, it's importing the contract that it's going to be testing, right? In order for Solidity to test Solidity, the Solidity needs to know the Solidity. This counter test file is pulling in counter. It's also pulling in this dstest test.sol. This is one of these things that's in the library that we've imported. And in fact, if we look up dstest source test.sol, we can see this file here comes with a number of fantastic functions like assert true to check to see if a condition is true, assert true with different parameters, assert equals decimals, a whole bunch of different asserts in here for us to actually do our tests. And we also install this HEVM from our utils folder. If we look in utils, we have this HEVM.sol. When you run your tests in DappTools, DappTools actually spins up a local HEVM blockchain that has some functions that allow us to actually control it, like warp, where we can set the block timestamp, or roll, where we can set the block number. This is obviously really helpful if we have any time or block-based functions. So we import the two of those into our counter test. Now we have some variables up at the top, of course, but the first thing that gets run in any of our tests is this setup function, where in this test, we're setting up some time, we're setting up a new counter contract, and we're also setting the specific time of the entire blockchain to some time that we wanted. Then we have a whole bunch of tests. You can see we have test check upkeep. We have some test name. It does some stuff, and then we assert whether it's true or not. DappTools will just go test by test, making sure things that asserts come out to be true. And that's it. So let's go ahead and design our own test for our Dapp lottery. All we want to do is check to see if we can start the lottery. So let's go ahead. We'll create a new file called Dapp lottery test.sol, and let's build this. So spdx license identifier. We'll say MIT. We'll do pragma solidity 0.8.0, and we'll call it contract. Dapp lottery test is ds test. We want our Dapp lottery test to inherit everything from ds test so we can have those assert commands. So of course, we need to go ahead and import them. Import ds test/test.sol. So let's go ahead and create that first function, the setup function, the setup for all of our tests. We'll do function setup public. Now we're probably going to want to have a Dapp lottery, so we're going to need to import that. So we'll do import /dapplottery.sol, and we'll probably want it to be a global variable here. So we'll say Dapp lottery public Dapp lottery, and then we'll say Dapp lottery equals new Dapp lottery, and then we'll add the construction parameters for our Dapp lottery. So if we look in Dapp lottery, we see it takes a key hash, a VRF coordinator, a link token, and a fee. Well, where do we get those from? Well, as we know, when we run our test, it's going to be running on a fake local blockchain where none of these actually exist. There's no link token deployed on a fake blockchain that we just deployed from scratch. This is where our mocks folder is going to come into play. We're going to mock and deploy our own fake link token as well as our own fake VRF coordinator, which is necessary for the Chainlink VRF. So the way we do that is at the top, we're going to import our mock link token. So we're going to do import./mocks /link token.sol. We're also going to import ./mocks /mock vrf coordinator.sol. And for those of you who have worked with Chainlink VRF before, you know that there's also an Oracle component in here. So we're going to do import ./mocks mock vrf oracle.sol. Or excuse me, it's in utils. I guess it could be in mocks, but it's currently in utils. In any case, now that we have those, let's go back to see what we need. Okay, we need a key hash. So we could really just give this anything as its key hash. So we'll just say bytes 32 public key hash, and then we'll just pass this as the input parameter. Since we're not actually going to assign it, it's just going to get defaulted to 0. Then we need a VRF coordinator address. We don't have that address, so we need to mock one. So up at the top, mock VRF coordinator, public VRF coordinator mock. And we'll do VRF coordinator mock equals new mock VRF coordinator. And then we can check what the mock VRF coordinator takes as input parameters. And it looks like it just takes a link token. So we're going to have to mock that too. So before we do this, we're just going to do, up at the top, we'll say link token, public link token. We'll say link token equals new link token, right like that. And then we'll pass the address of that link token to our VRF coordinator mock. Perfect. And now we can do address VRF coordinator mock for our next parameter. Okay, great. What's next? Perfect. The address of the link token. We can do address of the link token that we already deployed. And finally, we need a fee, which for our tests, we could set to really anything. So we'll just do uint 256 public fee. And we'll just pass that fee in here. Now that we have all of our setup done, we can go ahead and move forward with this. Now we're just going to run one test. We're going to say function test lottery can start, right? Because we have a start lottery function that calls the Chainlink VRF. First, we need to send some link token to our newly deployed DApp token contract. So that's pretty easy. We just do link token.transfer address DApp lottery. And then we'll give it, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be one link token. And then we'll make a request. Bytes 32 request ID is going to be equal to our DApp lottery dot start lottery. And then we're going to assert true that the request ID does not equal nothing. And what we can do to test this is we can do DApp test -m and then paste the name of that test. -m stands for match. So we're just matching the name of whatever comes after the M. And we're running it, and it looks like we do indeed pass, which is awesome. Now we can go ahead and cheat and look in the VRF consumer test.sol to see a little bit more interesting, that second test that it has in there, where we actually pretend to be the VRF Oracle ourselves and call back with randomness to make sure the rest of our code actually works. So that's definitely something to check out as well. But it looks like if we run DApp test, all of our tests are passing, including the new test that we just added from DappLotteryTest.sol, which is awesome. So we've created smart contracts. We've tested our smart contracts. Now we want to go ahead and deploy the smart contracts. Now, the way you deploy your smart contracts is with the dapp command create. So we can do dapp create and then the name of your contract. Ours is dapp lottery. Now, if we run this right now, we'll actually run into an error. We'll get this error saying eth from not set. Send from which account? It's looking for an eth from environment variable for us to be able to do all of this. The eth from is going to be the account that you want to send transactions from. We are going to be sending from our MetaMask. So we're going to come to our MetaMask. We're going to copy the address, and we could either do export eth from equals and paste our address in here and then hit enter, or we could add it in a new file called our .env. And we would do export eth from equals, and then paste your address in here. Now we could run source.env, which would activate our environment variables, but we don't want to do that because we'll have to do that every single time. So this is where, again, our makefile is going to come into play. At the top of our makefile, it has this line called -include.env. This means whenever we run a script from the makefile, it's going to automatically have anything from our .env automatically dropped in. And it looks like I actually put it in the wrong folder. I'm going to just move it into the right folder here. Okay, cool. Also, we can just say eth from equals this, and then run dapp create dapp lottery. And that'll do the same thing. Now when we run this, we'll run into a different issue. We'll run into this weird call stack HEM, but this is the actual error. Wrong number of arguments. As we know, our dapp lottery takes a number of arguments. It takes a key hash, a VRF coordinator, a link token, a fee, etc. So we'd have to add those afterwards as arguments. So we'd add like, key hash here, an address here, another address here, fee here. As you can see, these commands are starting to get pretty big. And this again is where our makefile is going to make that process also a lot easier. Plus, these addresses might change across networks. The VRF coordinator might be different on Coven, Rinkeby, Mainnet, Avalanche. The link token is going to be different. So we want some way to deploy to different networks and work with different networks easily. So if we go to our makefile, we can actually see there is a deploy command, which runs a command, right? Because we have the colon, semicolon, which means anything after is going to run a command called scripts deploy.sh. So if I run make deploy, it's going to run whatever is in deploy.sh. And it looks like it's getting a little confused and very angry, and that's okay. So if we go to deploy.sh, we can see what's actually in this file. First, we run this set-eo pipefail. This just will kill any command that breaks. We run this common.sh, which goes into this common.sh folder and pulls all these environment variables and all these different commands into our deploy script. We also pull in this helper config.sh. If we look in here, we can see a whole bunch of different arguments and parameters. Now, this is the file that we have that updates all of the arguments and parameters here. So if you see, if you scroll down a little bit, we have some if-then statements. So if we're on Coven, these are the variables that we're going to use. If we're on Rinkeby, we're going to use some different ones. If the contract is the counter contract, our arguments are going to be here. If the contract is price feed consumer, arguments are going to be price feed. If the contract is VRF consumer, those initial arguments are here. We're going to add one more now for our dapp lottery, saying else if contract equals dapp lottery. Our arguments are actually going to be the exact same as VRF consumer. So we pull in our helper config stuff. We look for a contract name, and we run deploy contract with the arguments. And again, if we look in common.sh, there is a deploy command right here that does all this stuff. And if you look, it does a whole bunch of wonderful stuff. But if you look down here, it finally runs exactly that command we were talking about, dapp create, name the contract, the arguments, it does some gas stuff, and then some RPC URL stuff, which we're going to talk about in a second. So I know there was a lot there, but this makefile really makes it easier to deploy across networks and with different parameters a lot easier. If you want, you can still 100% deploy things with dapp create. You're just going to have to add a whole bunch of flags and environment variables in here yourself. So the two environment variables that we need are going to be eth from and also export eth RPC URL. This is going to be your connection to the blockchain. If you wanted to, you could even use one of DappTools' built-in local blockchains. If you run dapp testnet, it'll actually spin up a fake blockchain that you could add to your MetaMask or do whatever you want with. But we're not going to use that. We want to actually deploy to something like Coven. So I'm going to go over to Alchemy and get a free Coven RPC URL. Once you sign in, you can create an app and then get a key or get an HTTP endpoint, which will look something like http alchemy.io/blah, blah, 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 something like that. For the purpose of this video, we're going to be deploying to Kovan, and I actually already have an environment variable called Kovan RPC URL that I'm going to be using in my .env file. But again, yours is going to be like something like HTTPS, blah, 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 whatever. Now that we have our eth from and our eth RPC URL, there's one more thing we need. To send transactions, including creating contracts, we need a private key. And that's where ethsign comes into play. Ethsign is another command line tool that comes installed with DappTools. So to add our private key, we'll do ethsign import. And this will give us a prompt to enter our hexadecimal private key, which again, we come to MetaMask, click the three dots, account details, export private key, add your password, and you'll get it there. You can then paste it in here. And after you do that, it'll prompt you for a password. And then once you enter, again, I've already done it, so I'm not doing it again. But once you hit enter, if you do ethsign ls, you'll see one, well, I have three here, but you'll see one key store. These are your encrypted private keys that can only be decrypted with your password. You'll want the private key, obviously, for the same address as your eth from. So, but once you have all that, we can finally go ahead and run our deploy command, right? So we could totally export, or we told eth URL or eth from equals, and then our from, and then eth RPC, URL equals, and then our thing, and then, dapp create, and then the name, and then all the arguments, and blah, blah, all that stuff. But again, our make file has that deploy helper here. So now we can run make deploy. And then we just have to choose our contract. We'll just say contract equals dapp lottery. And this again is going to run our deploy.sh, which is looking for the name of the contract. And that's how we define it right here by saying contract equals dapp lottery. Now, if we hit enter, what's going to happen? It's going to make this huge command here, seth send. So DappTools under the hood uses its own command called seth to actually create transactions. And then you're going to be prompted for your password to actually send this contract. So I'm going to enter my password in. It's going to go ahead and create a transaction for me. And finally, once it's deployed, it's going to give me an address here. So I can go ahead on Kovan Etherscan, pop that address in, and after a brief delay, we can see it right on Etherscan, contract created. We're going to additionally verify it later on once we get an Etherscan API key with something as simple as this. Again, that's in the README. All right, so the only last thing that we need to do is we need to know how to interact with these contracts. So how do we do that? Well, we do it mainly through our seth command. So seth has a whole bunch of different commands here, but the ones we're mainly concerned about are going to be call and send. So if we want to read something off of a contract that we've deployed, we'll use the call command. So for example, maybe I want to read what this fee is. I will do eth RPC URL, and then for me it's Kovan RPC URL. For you, it's going to be your alchemy key or infura or whatever it is. But we could do seth call the address of the address we want to call to, and then the function that we want to call. I guess let's just call random result, which right now is just going to be 0. So we'll say random result like that. For those of you who didn't know, any public variable is secretly just a view function. So that's why we have these parameters here, because this is kind of the same as if we had a function random result, right? And if our function took parameters, we would just do like uint256, bool or whatever, and then we would add them as arguments over here, like 55 and true or something like that, right? But since random result doesn't have any, we can just call like this, and we're going to expect to get 0 back, right? Because random result right now is nothing. And that's exactly what we see. Now we could additionally, instead of just reading off the blockchain, we could send a transaction by doing seth send. The only thing we'd have to add is eth from, which would be, an address here, our address. Seth send, the address of the contract, the function we want to call, and then any input parameters. I'm not going to run it right now just because obviously random result isn't one we want to send. But that's it. We've just gone through everything in this DappTools starter kit. Now, obviously, there's a ton more things to play with when it comes to DappTools, right? If you just look dapp help, There are all these different commands, all these different things in here. You can come say hi to them in their dapphub.chat where the team hangs out, answers questions, which is fantastic. Working with a tool like DappTools really is about as minimalistic, but also incredibly powerful as it gets. So hope you all learned something fantastic here and take it with you to your next project. So that's it. Remember to like and subscribe, and we'll see you next time.